Swayam Prabha. Digital India. Educated India.
Another important point regarding this op-amp is its slew rate. So what is this slew rate? Slew rate is the maximum rate of change in output voltage of an op-amp. So this is the maximum rate of change in the output voltage of an op-amp. So ideally, for example, let us consider that the case of a buffer or the voltage follower, where we have applied the signal here. This is the signal applied, this is the output, and output is basically shorted with this, the input inverting terminal, right? And here we know that if we whatever be the input, the output will follow that. That is true, but the change in this input cannot be followed immediately at this output. It takes some time, and the rate at which this output of an op-amp can change, that is also limited for an practical op-amp, right? And this rate of change is given in terms of this voltage per microsecond. For example, suppose for this op-amp the slew rate is given as 0.5 volt per microsecond. That means in 1 microsecond the output voltage op-amp can change at most 0.5 volt. It can change less than that, but it cannot, the rate of change of this output voltage cannot be higher than this, right? And I think it is not also very difficult to understand like why there should be such limitation, because this op-amp is actually constructed with different transistors. Transistor has its different stray capacitors, right? And that will create that some delay. So the input, right, or the change in input will not be reflected at this output immediately, or in other way, the output, the change in output, okay, cannot be like as instantaneous as this input, right? It has some its limit, right? So from that point of view, I think you can also guess that this slew rate then imposes some restriction on the maximum frequency or the amplitude of this input signal. Let's see how. For example, let us consider initially that we have a input signal which is basically a square wave, okay, and this square wave signal is being applied at this input, okay. Then what do we expect? As this is a buffer or the voltage follower, we expect the same output voltage or same square wave would be reflecting or coming to this output, right? But what happens practically? So this is the input signal, and let us say like this is 0 volt, this is 1 volt, okay, plus 1 volt, and this is, let us also say like this is 0, oh, time is 0, okay, in terms of time is starting from here, right? So this is the time 0, and let us say this is 4 microsecond, okay, this is 8 microsecond, right? So like that. So let us also draw then it here that this is the input, the black one, right? So black one is the input one, where this time is 0, this time is 4 microsecond, this time is 6 microsecond, should it be 6? It should be 8, right? And this is 12 microsecond, right? But here the slew rate of this op amp is given as 0.5 volt per microsecond, right? So if this is the input, then you can see to reach from this 0 voltage level to its plus 1 voltage level, this the output of this op amp will take at least 2 microseconds. So if it is 4 microseconds, so this is 2 microseconds. So the output of this op amp will be following this type of waveform, right? So when it is increasing, the input is increasing, output actually cannot increase or change its value instantaneously, but it will take some time, right, to change. Similarly, when the input is changing very sharply, the output cannot change again at the same time, but it has to fall with a finite slope, right? So this is that slope, right? It will take some time. Then again it will become 0, right? Again from here, this will take 2 microsecond from here to reach this 1 voltage plus 1 volt level, right? And then it will again fall down. So then if this is the input signal of this op amp, right, to this voltage, means if this is the input signal to this voltage follower or buffer, then at this output what we are getting is this type of trapezoidal output or waveform, right? It is not anymore an square waveform, right? But still we are able to get this, reach this plus 1 volt level, isn't it? Right. Now suppose you have later thought like, why to make it plus 1 volt, let us make it plus 3 volt. So now you are applying one square wave, maybe the frequency and time period are same, just you have increased its amplitude to plus 3 volt. So this is now changing from 0 to plus 3 volt, right? Then what do we expect at this output? So again, let us draw first the input part. So this is the input signal, right? Then okay, maybe I will also write that this is the input signal, this is the plus 3 volt, right? And let us pick another color to denote the output. So again this timing are the same. So this is 0, 4 microsecond, 8 microsecond, another 4, 12 microsecond, right? Then how the output will change? Remember this is plus 3 volt, right? So the output of this op amp in this case can at max change by in 1 microsecond 0.5 volt, right? So you have given a time of 4 microseconds. So in 4 microsecond it can reach up maximum to 2 volt, right? So it cannot reach up to plus 3 volt. So maximum it can reach for during this 4 microsecond time to this plus 2 volt, right? If we say that this is this plus 2 volt, right, then the output will be like this. Then after that again it will fall down, right, and it will fall like this, right, and here it will again rise like this, and that again it will fall down. So this will be the output waveform. So here you can see that the output waveform really is not able to reach the input voltage of that is been provided to this voltage follower, right? So that way you can clearly see that the output is actually getting distorted, right? So in this context, I think you have also noticed that to avoid this distortion, not only this the amplitude of this input signal is have to be considered, but at the same time this time, right, right? This time, or in other way, the frequency of this signal is equally important, right? Because think about it, instead of this 4 microsecond, if it was 12 microsecond, then definitely you would have reached 2 plus 3 volt, right? And the distortion will not be that severe, isn't it? So that way, two things are important. What is the input, right? The input amplitude of this input, that is definitely important. The other thing that we have seen, the input signal frequency, right? In the next case, we will also see, other than these two, the gain of this amplifier is also important, because this we are considering now the buffer or the voltage follower, so the gain is 1, so that part is not coming, right? But if there is a gain, then that gain will also affect, right, this distortion. So maybe in the next page, let us see the case of an non-inverting amplifier and try to understand this slew rate. So for this, let us consider this circuit. So as this is a non-inverting amplifier, so let us say that this is the input Vi, right? This is one resistance R1, maybe I will write it clearly here. This is R1, this has been grounded, and this is another resistor R2. This is the output, and say this input is an sinusoidal input, okay, whose magnitude is, like amplitude is Vm, and this is a sinusoidal, so the signal is sine of omega t. So Vi is actually equal to this, right? Then what will be the output here? So here the output would be equal to 1 plus R2 by R1, right? This is the gain of this non-inverting amplifier into this input. Input is Vm into sine of omega t, right? Then what is the rate of change in output? Rate of change in output. So that is nothing but dv naught by dt, we can find from here, right? So if you do that, right, then it will be this term 1 plus R2 by R1 into Vm into omega into cos of omega t, right? Then what is the maximum rate of change in this V output? Maximum rate will become when this cos value become equal to 1, right? So the maximum value of rate of change is this, right? Maximum rate of change in this output voltage. And you know that to avoid the distortion at this output, this maximum rate of change of this output has to be less than equal to lower than that of this slew rate, right? So what we can then write, this 1 plus R2 by R1 into Vm omega, this has to be less than this slew rate SR, right? Okay, what is this omega? Omega is the angular frequency, which we can also write in terms of 2 pi f. So it is 1 plus R2 by R1 Vm. This we can write 2 pi f. This is less than the slew rate. Now what is this f? This f is the maximum frequency, okay, for this case that is possible, right? Okay, so that you will not face any distortion at this output. Then what will be the value of this maximum frequency? Then the value of this maximum frequency should be less than equal to this 1 plus R2 by R1 into, obviously this 2 will be here, 2 pi term is also here, so it is 2 pi, right, into 1 plus this of this Vm, right. So if you now see this, so the maximum frequency, okay, at this input, so that there will be no distortion at this output, is given is dependent not only on the slew rate of this op amp, but it also depends on the amplitude of this input signal. At the same time, it also depends on the gain of this amplifier. So I hope then from this understanding, for any op amp circuit, you should be able to find what would be the maximum frequency of this input signal, so that that will not create any distortion at this output, right. Okay.